Good morning, students. Myself B.K. Mina, PGT Chemistry from Kendriya Vidyalaya, Nasirabad. Today, our topic is for solution of the equilibrium chapter number 7. So we start now according to their definitions of the buffer solutions. The such solutions which resist their pH change with time and addition of acid and base is called buffer solutions. And their types simple buffer solutions and mixed buffer solutions. And simple buffer solution, it is a mixture of weak acids and weak base. Here is HCN is a weak acids and NH4OH is a weak base to mix to each other to form the ammonium cyanide. And another example is ammonium acetate. Ammonium acetate is a mixture of acetic acid and ammonium hydroxides, and ammonium formate is a example of the simple buffer, which is a formic acid is a weak acid, whereas the ammonium hydroxide is a weak base. And ammonium benzoate is a another simple buffer which is formed by weak acid, benzoic acid. This is the benzoic acid and this is the ammonium hydroxide is a weak base. So weak acids and weak base mix to each other to form the simple buffer solutions. Whereas in case of the mixed buffer, these are two types, basic buffer and acidic buffer solutions. Now, and mixed buffer solutions, it contains a basic buffer solution, it contains equimolar concentration of base, weak base and its salts. Weak base and its salts with strong acids. Weak base and its salts plus strong acids. Suppose ammonium hydroxide is a weak base and hydrochloric acid is a strong acids. It mix to each other to give the salts and water. So this ammonium chloride salts is mixed with ammonium hydroxides, mixed to this ammonium chloride mixed to ammonium hydroxides to form the basic buffer solutions. Now another example is ammonium hydroxide plus ammonium sulfates and ammonium hydroxide plus ammonium bromide. These are the basic buffer solutions. Its the pH range is nearly equal to the 9.25 pH values, and now according to acidic buffer solutions, according to acidic buffer solutions, it contains weak acids and its salts plus strong base. So acetic acid is a weak acid, NaOH is a strong base to form sodium acetate. It is salts and water, and this sodium acetate is mixed with acetic acid to form base acidic buffer which have the pH value 4.74. The weak acid plus its conjugated base is also form acidic buffer. That is the CH3COH have conjugated base is acetate ions to form basic acidic buffer solution. Suppose another example is weak acids and weak salts of weak acids, formic acid and sodium potassium formate and acetic acid plus sodium acetate. Sodium formic acid plus sodium salt of formic acids. Now the conjugated acid base for this ammonia form the ammonium for conjugated acid by addition of the H plus ion and ammonia reduce minus H plus 2 is conjugated base of NH2 minus ions. Now, so here is a basic buffer solution and acidic buffer solution. We can derive the Henderson equation for these solutions, Henderson-Hessian-Place equations. Now the basic buffer solution Henderson equation is this. Now we derive it. We taking the weak base or salts of their weak base. At NH4 ammonium chlorides is a 100% ionized because it is a salts, and weak base NH4OH is a weak base. It split into ions in weakly ionized ammonium hydroxide, ammonium ion plus OH ions, weakly ionized. So apply law of mass action for weakly ionized substance. So Kb is equal to NH4 plus and OH ion concentration upon NH4OH, that is the product upon reactant. So OH is equal to OH minus ion is equal to Kb or NH4OH concentration upon NH4 plus ions. By taking the log of this equations, take on both sides, minus log OH minus is equal to minus log Kb minus log NH4OH upon NH4 plus ions. So minus log OH is equal to POH and minus log Kb is equal to PKb plus log salt upon base, because this sign is converted plus. So this value rearrange to down and this rearrange to up. Therefore, the rearranging this equation, so this equation is forms the ammonium ion. This rearranging equation is obtained in plus signs. So NH4 ion is a salts and NH4OH is a base. So POH is equal to PKb plus log salt upon base is a Henderson-Hessian-Place equation for the basic buffer solutions. Now, and the equation for acidic buffer solutions, the acetic buffer is acetate plus acetic acid plus sodium acetate, and sodium acetate is 100% ionized in their aqueous solutions, whereas acetate ion acetic acid is weakly ionized in their aqueous solution, convert into the acetate ion plus H plus. By applying the law of mass actions for weakly ionized substance, so Kb is equal to CH3COO minus upon and H plus ion and upon CH3COOH acetic acid, concentration of acetic acid. H plus ion concentration, so H plus ion concentration is equal to Kb as to concentration of acetic acid upon concentration of the acetate ion. Taking log of this equations, minus log is equal to minus log Kb minus log acetic acid concentration upon acetate ions. Now the pH is equal to this value equal to the pH, minus log Kb is equal to pKa minus log CH3COH is equal to CH3COH acetate ions. Then the rearrange this equation, this sign convert into the plus. Therefore, this raised to the up and this is down. Therefore, the pH is equal to pKa plus log salts upon acid, because this is the salts and this is the acids. So equation for basic buffer solution is Henderson equation for this, and acidic buffer solution Henderson equation for is equation 2. Now, if salt upon acid value, log salt upon acid value is 10, therefore pH is equal to pKa plus only. And if the salts upon acid is equal to 1 upon 10, therefore pH value is equal to pKa minus 1. The example is acetic acid, near about pKa value and pH value is equal to 4.8. So its value change up to range of 3.2 or 3.8 to 5.8. Plus means 1 plus add to this range to convert into 5.8, and minus 1 is equal to pH range is 3.8. That for today.